everyone. My name is Ritika Shukla and I am a student of class 6C. Have you ever wondered why do some objects float in water and why do some objects sink? What is causing them to float or to sink? The answer to this question is density. Density causes an object to float or to sink. So what does density means? So to understand density, we need to understand that everything around us is made up of small tiny balls called molecules. An object is considered to be more dense when its molecules are tightly packed and less dense when its molecules are loosely packed. But what density really means? So the real definition of density is mass per unit volume, which means if I took 1 unit volume and measured its mass, I will get the density of that object. So let's see this table which shows different material and their respective densities. Like for water, it is 1 gram per centimeter cube. For gold, it is 19.3 grams per centimeter cube. For lemon, it is 1.102 grams per centimeter cube, and so on. So these were some materials used in our day-to-day lives and their respective densities. So let's do an experiment to find out how density decides will it float or will it sink. First, I am using a pebble, a colored stone. It sank, right? Now, I would like to use this iron nail. It sank, right? Now, I would like to use this plastic ball. It is floating. Even if I am pressing it, it is floating. One more example. Let me take this and dip it. It's floating, right? So, every object that has density more than the density of water will sink in it. For example, the iron nail. Density of iron is more than the density of water, so it sinks. While the density of plastic is less than the density of water, so it is floating. Like if I take an ice cube and dip it into water, you can see it floating, but only 10% part of it is in air. About 90% part of its body is in water. Why is that? Because the density of water is 1 gram per centimeter cube and the density of ice is around 0.934 grams per centimeter cube, which is very close. That's why ice is almost floating and is almost inside water. So it shows that any object that is density less than the density of water will float, and any object that is density more than the density of water will sink. So let's do an experiment. I've taken a lemon here and put it over here. You see it sinks, right? It is obvious because we know every object that has density more than the density of water will sink in it, and it is obvious. But what if I add some salt in this water and mix it? I think it is mixed. And then I add this lemon, which is almost about the same size. It is floating, right? But what's the difference? The density of the lemon is same, but why this type of lemon is floating? It is due to the density of water. In this glass, it is normal water, and the density of normal water is 1 gram per centimeter cube, and the density of lemon is greater than this. That's why the lemon sank. But in this case, it is not only water, it's a salt solution, and when salts get added to water, the density of water increases. That's why in this case the lemon is floating. because now the density of water is more than the density of lemon. That's why it is floating. But in some cases, lemon can float in normal water too, because there is a process in which any object soaks up water or any other substances which is around it. So after some time, this lemon will absorb some of the water over here, and the amount of mass present in it, which is its density, will get decreased, and after some time it will rise up. That's why in markets we see that lemons are floating, but when we try it at home, this sinks. Now let's come to one thing which is very interesting. See this ball. When I am trying to push it down, and the moment I remove my hand, the ball bounces up and comes up. Let me do it again. The same is happening. But why so? To explain this, we can say that a force might be acting on it to make it up. An upward force might be acting on it. So how much the upward force will be? So upward force will trying to push it up. And when I am moving it down, the upward force will try its best to put it up. But it is not able to. And the moment I remove my hand, the force is free and it acts on the object, and the object, which is ball here, rises up. Which means an upward force is acting on the ball, and this force is called buoyant force. Mr. Archimedes was the first person to observe this force, and this is one of the part of the principle of Archimedes. Then the second principle is, see, now the water surface is plain, but what if I do something like this? The water is being disturbed. It is moving, right? Let me do it again. The water is being disturbed, or I can say it is being displaced. So let me do it again. You see, it's being displaced. So, for example, if this much amount of water is being displaced, and I have taken in a beaker, and now I have measured how much it weighs. If it weighs around 10 grams, then there was an upward force, the buoyant force, right? So the buoyant force will be equal to 10 grams, which in words equal to 10 gram force. Then the second statement states that the force will be equal to the amount and the weight of the water displaced by the object. It is fluid, but in our case it is water. So I am saying that it is water. And on the same principle, those large heavy ships work. Have you ever noticed the base of a ship? It is long and broad, which increases the amount of displacement, which increases the amount of buoyant force acting on it. So the ship is stable, and on this principle only the ship works. So the time to conclude. The two conditions required for an object to float are: first, the object density should be less than the density of the fluid in which is floating. Like here, the density of this plastic is less than the density of water. That's why it's floating. And the second thing, the weight of the object should be less than the weight of the water displaced by it. Right? Then, buoyant force. If the buoyant force is less than the weight of the object will sink. But if the buoyant force is more than the weight of the object will float. Or if it is around equal to the weight of the object, it will sink and float, like it was in the case of ice. Thank you.